On a no-cool call, always start at the thermostat to make sure that this is not the problem. Then move to the air handler and check to make sure the filter, squirrel cage, and evaporator coil are clean and that the blower is functioning correctly. Only then should you move outside to work on the condenser. In this case, nothing was working and the breaker was tripped. After turning on the breaker, it was found that the contactor was closed and was passing 240 volts to the T1, T2 terminals. The fan motor was running, but the compressor was not. Turning off the power, the capacitor was checked and found to be normal. This now only leaves the compressor. In a normal compressor, the readings between the three terminals should read as follows. The common and run should be very low, say 0.6 ohms. Common and start should be higher due to the greater density start winding, generally about twice the CR reading, say 1.1 ohms. The reading between run and start should be equal to the sum of the other two readings, namely 1.7 ohms. Now let's test the faulty compressor. Start by removing the common and run wires from the contactor and removing the start wire from the capacitor. Test each pair of wires. Between C and R, we had an open leg, meaning that the wire inside the compressor is broken. This is a kiss of death for a compressor, since there's no way to get inside a hermetically sealed compressor to fix it. But to make sure that it's not the wiring harness that's bad, we need to directly test the terminals on the compressor. Between C and R, we have an open leg. Between C and S, we have 23 ohms, which is way too high. And finally, between R and S, we have an open leg, which was expected since the CR leg was open. The compressor is bad and must be replaced. On Goodman condensers, the first two digits of the serial number indicate the year of manufacture, and the second two digits indicate the month of manufacture. So this unit was made in July of 2007. The homeowner decided to replace the entire condenser rather than opt for a compressor replacement. But why did the compressor die? Two reasons. After removing the cover from the condenser, it immediately became clear why this unit overheated. The condenser coil was caked with debris caused by years of inattention. This is why every air conditioner should be serviced each year. The other reason was that the unit did not have a high-pressure cutout, which would have shut the unit down when the pressure grew too high. As far as cleaning the coil is concerned, use a nylon coil brush and gently stroke in the direction of the fins. The debris will come right off without damaging the coil. Brushing in the wrong direction leads to catastrophic coil damage. This applies to evaporator coils as well. The new condenser was installed, this time with a high-pressure cutout, which breaks the 24 volts going to the contactor and thus shutting off the unit. Also, the old 50 amp breaker was replaced with a 30 amp breaker, which is all that is required for the new, more efficient condenser.